Well, hello guys, here Mr. G with another question from the mid-year diagnostic exam. This one is the second question, question 2, and it is related to naming organic compound. This one was done at the Northern Cape in 2023 and developed by Professor Rodriguez. The letter A to H in the table represent 8 organic compounds. And you have the organic compounds here, which we are going to quickly identify what is the homologous series. For instance, A, you have the OH here bonded to a carbon, and this one is going to be an alcohol. Okay. The second compound, compound B, you have the carbon here with a hydrogen and a double bond to O, so that one is going to be an aldehyde. Compound C, now it's a little bit tricky. There is only carbon and hydrogens. We're going to leave this one for a little bit later, but we are going to write that it's a hydrocarbon. Compound D, you have a carbon and hydrogen, but you also have a bromo there. In fact, you have 2 bromos there, and therefore this one is a haloalkane. Compound E is a propanoic acid, and then it is ending in oic acid, guys, is a carboxylic acid. Compound F, only carbon and hydrogens, and is therefore a hydrocarbon, the same as compound C. This one is a hydrocarbon. All right. Compound G, this is another hydrocarbon. We have 3 hydrocarbons in this question. It's a hydrocarbon, and compound H is ending in on, and therefore is a ketone. Guys, we have done here now, we identify each of the different compounds that we have from A to H. If we're going to answer, say, write down the letter that represent a compound with a carboxyl group as a functional group. Now, the compound that we'll have here, a carboxyl group, is a carboxylic acid. Remember, carboxylic acid, carboxylic is coming from carboxyl group. So carboxylic acid. And we identified before, so we know it is going to be compound E. An alkene, now for the alkene, remember we have 3 possible options here, which are the 3 hydrocarbons. So we have compound C, we have compound F, and we have compound G. All of them could be either an alkene, alkane, or alkyne. Okay, now to do this one, we are going to use the general formula. Now, the general formula for alkene is CnH2n. This one is the general formula for alkene, and all alkenes, it doesn't matter what alkene we have, will follow under this general formula. Guys, all we have to do is count the number of carbon in each of them and then see how many hydrogen should there be. So, for instance, we're going to start for compound C, and let's count the carbon. We have 2 carbons here because it's 1 there, but this bracket is for everything. So we have in 2 carbons, 3, 4, 5, 6, 7, and 8 carbons. So in this compound we have 8 carbons. According to this general formula, if you have 8 carbons, how many hydrogen you should have? You should have 2 times 8. That will be equal to carbon 8, hydrogen 16. So in other words, if you have 8 carbon, you should have 16 hydrogens. Just changing that little color there. So let's go back to the equation here, to the formula, and count the number of hydrogens we have. And be careful because it could be tricky. For instance, hydrogen, we have 3 at the beginning here, but we have a 2 outside in the bracket. So in other words, 3 times 2, which is 6, 7, 8. 8 plus 3 is 11, 12 and 13, 14, 15, and 16. So in this case, we have 16 hydrogen. Therefore, C is an alkene. So let's write it here. Alkene. alkene. All right, so you can see that compound C is the answer for this specific question. They say an alkene. Now let's try the other ones quickly, and you know how to do it now. So if we count for F, for instance, the general formula or the molecular formula, you have how many carbons? Let's count the carbons. 1, 2, 3, 4, 5, 6, 7, and 8. We have 8 carbons. How many hydrogens do we have here? And let's count real fast. We have 3 hydrogens, 4 plus 5 is 9 here, 9, 10 and 11, 12, 13 and 14. So we have 14 hydrogen, and you can see it doesn't follow under that general formula. So it is not an alkene. And if we count the last hydrocarbon here, we have 2 carbons, 2, 3, 4, 5, 6, 7 and 8. Also 8 carbons here, but the hydrogen we have 3 times 2 is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. We have 18 hydrogens, and therefore it also doesn't follow under the alkenes. So this one is 18. So guys, the answer for that question is only C. I hope you understand. We did just practice how to apply or use the general formula. Which one is an aldehyde? And remember, we did identify at the beginning the aldehyde is compound B. A saturated hydrocarbon. Now, saturated hydrocarbon, remember, you have a single bond between carbon. So we're looking for a hydrocarbon that have only single bond between carbons. In other words, we are looking for alkanes. Alright, and now guys, for alkane we are going to do similar to what we did in 2.1.2. We're going to look for the general formula. Now the general formula for alkane, guys, is CnH2n+2. So if we go here, know that all the hydrocarbons, this work was done already previously. All the hydrocarbons we have, C cannot be because C is an alkene. So it's between G and F. Now, according to this, all of them have 8 carbons. According to this one, if we have 8 carbons, how many hydrogens we should have? Is 2 times 8 plus 2. 2 times 8 is 16, so it is C8, H. 2 times 8 is 16 plus 2 is 18. Which one is the one that follows under that one? Is compound G, and therefore that is the answer for this question. I hope you understand. It's a very good question to practice. 2.1.5, 2 compounds that are functional isomers. Now, functional isomers, just to recall, very quick, have the same molecular formula, different functional group. So we're looking for compounds that have the same molecular formula but different functional group, guys, and there are only 2 combinations we can look for. And these combinations are carboxylic acid and esters, and ketones and aldehydes. In other words, if you're looking for a functional isomer of a carboxylic acid, then it should be an ester, or vice versa. And if you get to look for a functional isomer of a ketone, you're looking for an aldehyde. Now, if we got here, we don't have any ester, guys. We only have one carboxylic acid, but there is no esters. However, there is an aldehyde and there is a ketone. Therefore, the compounds that are functional isomer will be B and H. So the answer for 2.1.5 is B and H. That is the answer for that question. Write down the IUPAC name of B, F, and G. So let's take here compound B is aldehyde. Let's write that compound real fast. Okay, so here is compound B. Let's write the name of this compound. Step 1 is to identify the homologous series, and remember it was an aldehyde. Let's fix this one. And therefore the compound will finish in al. Alright, that is the first thing we get here. Second option is to look for the longest continuous carbon chain. Guys, we have 2 continuous carbon chain there. One of them is when you go all the way down here. This is continuous carbon chain. There we go. That contains the functional group of course. In this case, we have 1, 2, 3, 4, and 5 carbons. 5 carbons. But we can also go straight. For instance, go all this way here, and then you can see that we have 1, 2, 3, and 4 carbons. So the 5 carbon is the longest one. Now 5 carbons is going to be pent. So in this case, it's going to be pent. But because it's an aldehyde, you're going to write pentan. So it's not just going to be pent, but pentan. This one is the second step. Then you are going to give or number the carbons starting from the end nearest to the functional group, which in this case is the first carbon. So this is carbon 1, 2, 3, 4, and 5. That is the one. But now we are going to look for the substituent. In this case, we have here a methyl group. This one here is a methyl group, and it is, let's write it here, methyl, and you can see it's in carbon 3. So you write 3-methyl. Guys, we have everything. All we have to do is to combine. So we're starting by saying 3-methyl pentan together, pentanal. 3-methyl pentanal. This one is the name of compound B. Alright, and this one is compound F. Now, the first thing I recommend is to try to convert this condensed formula into structural formula, because it will be easier to understand. So here we have a carbon with 3 hydrogens. We're going to finish everything right now. Then we have here bonded to a carbon. There is another carbon. So for this first carbon to have 4 bonds must be 1, 2, 3, and 4. Okay? Then is another carbon there. So this one is bonded to another carbon, which is bonded to a hydrogen. And this here means that is a substituent, is bonded all that to this carbon there. So we have here now 2 carbons, 1 and 2 carbons with 5 hydrogen, which means this one will have 1, 2, 3, 4. I'm moving up a little bit, and 5. Then we continue here. This carbon is connected to 2 hydrogens, 1 top, 1 bottom, and the final carbon is connected to 3 hydrogens. So let's complete all the hydrogen we have left. Now you make sure all the carbon, or each carbon, will have 4 bonds. Otherwise, everything is going to be wrong. Okay? So now the first step is to find out the homology series. This one is going to be an alkyne. And then 4 is going to finish or end in -ine. That is the first part of all. Second part, we're looking for the longest continuous carbon chain that contain the functional group. And in this case, we have 2 options. Option 1, when you go all the way straight, that is going to give us 1, 2, 3, 4, 5, and 6 carbon. If we take this one, is 6 carbons. And then the second option is also straight up until the 4th carbon, like for instance starting from here all the way there and then goes down. And if you take this red one and you count, it's 1, 2, 3, 4, 5, and also 6 carbon. So both of them have 6. Then we're going to take the straight one. Okay, that is the second step. 6 carbon is going to be hex. So we're going for hex. All right, there is the second step. Now we are going to be numbering the carbon starting from the end nearest to the functional group, and you can see easily that this one is the closest one. So 1, 2, 3, 4, 5, and 6. And now we have to say in which carbon is the functional group. In this case, it's in carbon 2. So we go all the way there and we write 2-ine. All right, that is the place of the carbon in which the functional group is allocated. Okay. And then we go and we look for any substituent. Here, the only one is this one, which is an ethyl. And that ethyl is in the 4 carbon. So it's 4 ethyl. Guys, that is all. All we have to do now is to combine the name. And the name will be 4-ethyl hex, you stop there, 2-ine. That is the name of the compound. Let's just move it a little bit to here. That is the name of the compound. I hope you understand. And then the last one is compound G. We're going to do compound G, and we're going to use the same approach. And for this approach, the first thing we're going to do is to convert this condensed formula into a structural formula. Remember, this bracket means a substituent or alkyl group. So what we have 2CH3. So we have one carbon which have 3 hydrogens, as it is here, and that is 2 of them connected to a carbon. So here is one, there is a carbon, and there is another CH3. All right, note the following. Here you have one carbon, these 2 CH3s here, as you can see, are connected to that carbon there, and that carbon is also having a connection to one hydrogen. So here, that is the first thing we have. This one is a little bit tricky to understand what is going on there. Now this one is connected to a carbon which have 2 hydrogens. It's connected to another carbon with 1 hydrogen, and another alkyl group is CH3. And then is a carbon with 2 hydrogens, and there is a carbon with 3 hydrogens. So this is what we actually have here. Okay, this is the compound. Now make sure you have 1, 2, 3, 4, 5, 6, 7, and 8 carbons. So it should be all right. Be careful if you do this one when you don't make a mistake. Okay, guys, you can see that this one is an alkane, and therefore will end in ane. Okay, now the second step for alkanes is a little bit tricky. We're going to look for the longest continuous carbon chain, and you can see is the straightforward. It's very simple to see it, guys. It's nothing to stress about. That one you can see clear. It is very, very long. Okay, so now how many carbons are there? 1, 2, 3, 4, 5, and 6. So we are also going for hex. This one has 6 carbons. Let's fix this one. 6 carbon, and it's therefore hex. All right, we are by hex. Now the numbering of the carbon, you are going to start from the end nearest to the substituents, but sometimes you'll have to count. I hope one day we'll get an example in which we counted. I have videos on that one. In this case, you can see that the first substituent is in the second carbon. So 1, 2, 3, 4, 5, and 6. Okay, so that is the first substituent there. We have a substituent in this carbon here, and we have a substituent in this carbon here. You know what, let's do the calculation so you understand, in case sometimes it's difficult. So when you do calculation, you're going to number the carbon starting from both ends. For instance, this is the red one, and then you can also start like 1, 2, 3, 4, 5, and 6. So we have 2 options. We are going to do 2 calculations. How is it done? For the red one, you are going to add the 2 because the first substituent is there, and the 4 because the second substituent is there. Let us get the substituent so you know what I'm talking about. Here is one substituent. In this case, it's a methyl. And here we have another substituent. That one is another methyl. So I'm going to add the carbons in which the substituents are allocated. So in this case it's 2. So I'm going to say 2 plus the second substituent is in 4 is equal plus 4 is equal to 6. Okay, that is for the red one, option 1. Option 1. Option 2, we are going to use the purple one. Now if we go to the substituents, we have 3. Here is the 3 plus 5. So we come here and we say option 2, and we say 3 plus 5, and that gives you 8. So we have 6 and 8. Therefore, we are going to take always the less combination or the smaller combination. In other words, this is the combination we are going to take. If we do that, then we have a methyl in the second carbon. So we have 2 methyl, and we have a methyl in the fourth carbon, 4 methyl. How do you combine this together? We say 2, 4 dimethyl. I'm doing it very slow because this one could be tricky. Guys, we are done. Now we have to combine the names. So the name of the compound is going to be, let's cancel this one. This one is not the option, the proper one. The name of the compound will be 2, 4 dimethyl hex N there at the end. So it's 2, 4 dimethyl hexane. That is the answer for this specific question. Question 2.3. Write down the structural formula for compound D, and compound D is a haloalkane. So here is compound D. 1, 2 dibromo 3-methyl-butane. Now in this work, we are all going to start by writing the number of carbons. It is bute, so I'm going to have 4 carbons, 1, 2, 3, and 4 in straight line. Remember, bute means 4 carbons. All right. Then I'm going to look for the functional group. In this case, it's a haloalkane, so there is going to be single bond between all those carbons. And then I'm going to start completing the rest. Now, in this case, my first carbon is going to be on the left, 2, 3, and 4. Those are the carbons. Remember, we have to remove all those numbering, okay? So you do it with pencil. Now, in carbon 1, I have a bromo. It is in this side here. In carbon 1 and 2, I have 2 bromos. So in carbon 1, I have a bromo, is a Br, and in carbon 2, I have a bromo, which is another Br. Now I'm going to the other substituent. In carbon 3, I have a methyl. So in carbon 3, I have a carbon with 3 hydrogens. There we go. I'm going to do it this way. And then, guys, we are done. The rest is make sure you combine and complete the other hydrogen. So this one is that compound is quite simple. I hope you understand. Question 2.3.2, compound H. Now, this one, remember, was a ketone. It ends in O, and we have pent. So pent is 5. And guys, I'm going to do first the 5 carbons. I'm going to write 5 carbon in a straight line. So it's 1, 2, 3, 4, and 5. I didn't write the functional group yet. I'm going to give numbers of carbon like 1, 2, 3, 4, and 5. And they're telling me that in the second carbon here is the functional group. So 1, 2, functional group of ketone is double bond O. Then in the fourth carbon, I have a methyl. So in this carbon, I have a carbon with 3 hydrogen, which is a methyl. And that is the end. All I have to do now is to combine the carbon as well as the hydrogen. Make sure every carbon has 4 bonds. In this case, it's 1, 2, 3, and 4. So here is hydrogen, 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 and then 3 hydrogens at the end. And this one is the end of this question 2.3. I hope you understand. It's a very good question. Okay. Question 2.4. The IUPAC name of organic compound is 4, 4 dimethyl pent-2-ine. Now we're looking for a ine, which in other words is going to be an alkyne. And the first question says, write the general formula of the homologous series to which this compound belongs. So nothing to say, you have to learn those general formulas by heart. We did practice a lot in this question. So it's Cn H2n minus 2. That is the general formula for alkyne. Write down the structural formula for this compound, and we practice a lot. So let's write the structural formula for this one. So once more, we have to write the general formula. All we are going to do is to look for pent first. We're always going to follow that trend. So it's 5 carbons. Remember, pent is 5 carbons. So I'm going to draw 5 carbons in straight line. So it's going to be 1, 2, 3, 4, and 5 carbon in a straight line, and I didn't do the joining yet. Now in the second carbon, I'm going to have a triple bond. So 1, 2, there is triple bond here. In the 4 carbon, there is 2 methyls here. So 1, 2, 3. In the 4 carbon, there are 2 methyls. One at the bottom, CH3. Let's fix that. Oh man, fix that one there, here, and there. And then here is another carbon with 3 hydrogens. And then, guys, it is done. All we have to do is to combine the carbons and make sure you have 4 bonds in each carbon there. Hydrogens, this one is the answer for this specific question. Be careful there because each of them will already have 4 bonds. So guys, this is the answer for question 2.4.2. This is a very long question. Question 2.5. The organic compound below has 1 positional isomer and 1 functional isomer. And then you have this compound which you know it is a ketone. If you look at the functional group here, that is telling you that this compound is a ketone, and it's very important. Okay, so now define the term positional isomer. What is a positional isomer? They are compounds with the same molecular formula, important, but different position of the functional group. Question 2.5.2. For this compound, write down the IUPAC name of its positional isomer. Now, the positional isomer, guys, will be when the functional group change position. So this part here will change places and will move there. That is all it's going to happen there for the positional isomer. So in other words, this is how it's going to look, the positional isomer. Okay, you can see there on this side that the place of the functional group changed. They're asking you now for the IUPAC name. This one is straightforward. We don't have to follow the steps too much. It is a ketone and therefore will finish or will end in on. The longest carbon chain is only 1 carbon chain, is straightforward, and then you have to count from the end, starting from the closest one. At this specific point, the functional group is in the carbon 3, which is the middle carbon there. From any place you start, 1, 2, 3, 1, 2, and 3. So it must be given here in the carbon in which the functional group is allocated. It is 5, so it's pent. Then you say pentan because it's a ketone, guys, and thus it's no substitute, nothing else. The name of this compound is going to be pentan 3-on. That is the answer for the positional isomer of that compound. Structural formula of its functional isomer. Now remember, previously here we mentioned at the beginning of this question, here we mentioned the functional isomer of a ketone must be an aldehyde. Now they want the structural formula of the functional isomer. To make this one an aldehyde, all you have to do is to move the functional group to the end. So in other words, this one here will be question 2.5.3, and this one is, guys, the functional isomer. So this one here is the functional isomer. There we go with that question, guys. Now we're going to the final part of this long question. Consider the condensed structural formula of an organic compound below. And then you have the structural formula. It is a primary, secondary, or tertiary alcohol. Now be careful. Be careful with this one. So the first thing we're going to do once more is to convert this one into structural formula. So we have a carbon with 3 hydrogens. That carbon is connected to a carbon with 2 hydrogens. That carbon is connected to a carbon which have the OH. I'm going to do the OH like that. And there is a functional substituent connected there, which is a CH3. Remember, this one represents substituents or alkyl group in brackets. And then you have the final carbon with 3 hydrogens. They don't ask naming, they're asking you what type of alcohol is this. You can see that the OH is connected to a carbon, and that carbon is connected to 3 carbons, as you can see there. There are 3 carbons connected to the carbon of the OH. Therefore, you can see there the 3 carbons. Therefore, this alcohol is going to be a tertiary alcohol. Give a reason for your answer. The OH is connected or is bonded to a carbon which is bonded to 3 carbons. There is the answer. Guys, this is the end of this video. It's 27 marks. It's a lot of marks for it. I hope it helped. If it helped, thumb up. Subscribe for the channel. I'll see you next time. Next time we're going to continue answering this question paper, and it's going to be related to physical properties, a very important question for the test. Thank you for watching. Subscribe for the channel. I'll see you next time. Mr. G here.